So we're going to be focusing on stereoisomers of carbon-containing molecules, and the term chiral is going to be used a lot. So let's look at what that means. Chiral means that the mirror image of something that is chiral is not superimposable. So what the heck does that mean? Well, we're going to use our hands because we're very familiar with how our hands work and what happens when you try to put the wrong glove on. So if we look at our hands, my left hand is a mirror image of my right hand. So that's our mirror image. And this mirror image is not superimposable. So if I put my left hand and try and superimpose my right hand above it, it's not superimposable. My thumbs are on the opposite side, my pinkies are on the opposite side. So this is not superimposable. On the other hand, if I have a glass and I look at the mirror image of the glass, I can superimpose it on itself. So that would not be chiral. So chiral means we cannot superimpose the mirror image. Now we'll be looking at some tools to figure out how we can determine if a carbon is chiral or not. But before we do, let's look at this molecule on the slide because this is a chiral carbon. So remember that black stands for carbon, and we have a simple molecule, carbon, with 4 single bonds to 4 different substituents. And if we look at its mirror image, we will see it is not superimposable on the original, just like my right hand is not superimposable on my left hand. So if we take the carbon of our image and put it on the carbon of the original, we see that the blue and the red atoms would superimpose on one another. However, the image where the green atom is where the original has a yellow atom. And where the image has a yellow atom is where the original has a green atom. And no matter how you rotate the image and the original, you cannot get one to superimpose on the other, just like you can't get your left hand to superimpose on your right hand no matter how you twist it. So that's what chirality means. So the term chiral comes from the Greek word for hand, and so we often interchange handedness for chirality. And as I said earlier, not all objects are chiral. So for example, if we look at this chair, it is not chiral. Its image is superimposable upon itself. And also if we look at this molecule, also a simple molecule with carbon in the center with 4 single bonds, this is not a chiral molecule. Let's take a look at it. If I take this mirror image, put my black carbon here, put my red carbon here, put my yellow carbon here, so those are all superimposed, then my 2 white carbons will be superimposed on one another. So one way you can tell if a molecule is, or anything, is achiral or not chiral is if there's a plane of symmetry in the object itself. So if I look at a chair and I just cut it down the center, there is symmetry. Both sides are the same. Same thing if I look at this molecule that I showed on the previous slide. If I cut it down the center, where the center is defined by where the red and the yellow atoms are, if that's my center, then there's a white atom on either side. And we see a similar molecule here, where we have a carbon that has 3 different substituents, 4 bonds, but 3 different substituents, chlorine, methyl, and 2 hydrogens. If I look at this plane of symmetry between my chlorine, my carbon, and my methyl, on either side of that plane, I have hydrogens exactly the same. So both this chair and this molecule are achiral, but this last example here, C, this carbon with 4 different substituents, it doesn't have that plane of symmetry. There's no place where I can cut it in half and have the exact same thing on both sides of that plane of symmetry. So chiral molecules and chiral things in general lack that plane of symmetry. If I take my hand and I cut it down the middle, it's not symmetric on both sides. I have my pinky and my thumb on either side, and there's no way that I can find a plane of symmetry where both sides of my hand, whether it's left or right, are going to be the same on both sides. So now that we have a better understanding of what chirality is, the next lecture we're going to look at how to identify whether a carbon is chiral. chiral or not just by looking at its formula or its structure.